questions you have to ask yourself before even going out and assessing how and where you're going to deploy monitoring points in the topology. Are you interested in monitoring things like application performance? Is NetFlow and SFlow important to you? Do you want to be able to do forensics? And we're going to talk more about that in a minute. I've referred to that in other parts in these slides as post-incident analysis, that they're one and the same, forensics and post-incident analysis. Do you have virtual servers and virtual applications out there as well that perhaps are giving you a problem? Are you trying to monitor voice over IP and video? Is there wireless in the network as well? Are there 10 gig segments? All of this factors into the type of equipment that one might deploy, as well as the measurement points, the monitoring points that you may enable in the network. So now in terms of more of an overall topology, again, it's different for everybody. What I tried to capture here is, a somewhat typical distributed environment where you may have a centrally located, but perhaps not on the corporate campus, a network operations center. Associated with that is a data center, server farms, etc. That is certainly one of the points where one would want to be monitoring. There's probably very little wireless in the network operations center, so we don't really need to worry about that component there. But we certainly are going to have, gig and probably 10 gig as well in that area. It's going to be the area where pretty much, all of the packets that are going out, back over the internet are funneling through. So we may want to have the ability with something like a larger appliance where we're not only able to capture and analyze all of the packets, but store those packets as well. So that way, if there is a problem, maybe it's happened a few minutes ago, maybe it happened several hours ago, we would still have the packet files available to go back, not have to reproduce that issue, but be able to basically play back that issue and do our analysis, right from the start. Over in the data center, again, we may put another supercore over there so that we're making sure that we capture all of the packets that traverse the data center. And in the area where there's the server farm, if there's if there's virtual applications there, virtual servers, we may need to run some software that allows us to be able to see that virtual traffic, because virtual traffic provides some unique challenges of its own, because often if the traffic between maybe like the application server and the database is all resident on the same virtual machine, you wouldn't see those packets actually ever traverse a real network interface card or some other type of NIC. And you would then never see those packets and basically never see that data. You may not even see it through NetFlow or SFlow, again, because it's not going out maybe through a switch or through a router. So there's special software, and from us, we have a product called OmniVirtual, where you're able to see the data from within the virtual machine, and that makes it very useful. Going out from the network operations center and the data center, you may have some remote offices, the corporate campus, also some remote users. And in each one of those cases, the types of technologies being used for networking may be a little bit different, and you would need to deploy things in a different manner. Starting on the left with the remote users, maybe most of those are wireless remote users. So you would want to then be capturing data either from their desktops or over the wireless network using various technologies to be able to capture the wireless part of the data. Capturing wireless is a very local type event. It's very dependent on the point of presence. You need to be in that 300-foot radius or so that's in the range of that particular access point. So it's very, very localized, and there are ways to do that either with remote sensors or by turning certain access points into sensors, et cetera, to be able to monitor that kind of data. At the corporate campus, of course, we're going to have probably a pretty complex wired network, along with perhaps some wireless as well. And depending on the level at that corporate campus and the amount of applications and data that are resident just within the campus, you may or may not want to be able to store the packets with a appliance that's got a lot of disk space in it, like the OmniAppliance Core, or you may just want just to monitor that particular area, knowing that all of those packets are also funneling back through the Network Operations Center and the data center, and actually archive them at that point. Again, there may be some wireless at that point, and you may want to look at what's going on the individual desktops as well. Out at the remote office, again, there might be a lot going on out at that remote office, but we know for sure everything from that remote office is funneling back through the Network Operations Center and the data center. So there's no need out there to have an appliance that's going to be able to store packets. We may have just our OmniAppliance Edge, which has some storage capability, but much smaller. You're basically able to monitor and analyze networks up to gig networks, and that would be sufficient for monitoring at that remote office. But the key point here is that at each one of the core areas, like the Network Operations Center, the data center, certainly our remote office and our corporate campus, it's important to have some level of visibility in each of those areas. Whether that visibility, is just at a 1 gig level, because we know we've got a 1 gig network there without the capability to capture, to store the packets, to archive them long term, all the way up to appliances where we can put in several 10 gig cards, multi-port 10 gig cards, and be able to have the disk storage available to be able to archive those packets, so we don't need to go out and reproduce network problems.